Algebra 2, state sample question number 16. Two versions of a standardized test are given, an April version and a May version. The statistics for the April version show a mean score of 480 and a standard deviation of 24. So April's mean is 480 and April's standard deviation is 24. And the May test, the May's version, shows a mean score of 510. So the mean for the May is 510, and the mean standard deviation is 20. Assume the scores are normally distributed. Okay. Joanne took the April version and scored in the interval 510 to 540. What is the probability to the nearest 10,000? Now 10,000, that's 10 and then 1,000. Notice that that's 4 decimal places. So 4 zeros, we're going to go 4 decimal places deep. That a test paper selected at random from the April version scored in that same interval. We basically want what is the probability of this interval. To do this, we use our calculator, and what we need to know before we type into our calculator is we need a lower, an upper, what they call mu, which is probably the symbol I should be using here, mu, because these are population averages, not sample averages, and a standard deviation, which would be sigma instead of sample. So didn't really use the proper symbols here because these are population measures, the population on the April test, the May test, and things like that. So let me actually put the right symbols there. And we'll see those in our calculator when we hit second vars and choice number 2, normal CDF. So get rid of that. And here I got to clear that. So we have lower, upper. That's called mu. Looks like a U. It's a symbol mu. And sigma. I even write my mu's wrong. So let me put those there. So mu, the Greek letter. It's the symbol for the average of a population. And sigma is our standard deviation for a population. Before I was using X bar and SX. That's what we use for sample average and sample standard deviation. Like if they said, 100 of the students that took the April version, their average was this and their standard deviation. But they're saying the April version, so that's the population of the April version. And let me also flip my mu symbol around to the right way. And so the April average, the May average, and the April standard deviation, and the May standard deviation. All right, so for a lower, we're going to use the 510 and the upper 540. So when they give you the probability of an interval probability, the interval is your lower and upper. And then the mu, because we're talking about the April test, is the average of 480. And the standard deviation of 24. And so this is what I need to type in here. 510, 540, 480, and 24. And then we hit paste, and it pastes it basically into normal CDF, but in parentheses. So if you have an older calculator, this is actually what you need to type in. You just type in lower, comma, upper, comma, average, comma, standard deviation, and then hit enter, and it'll give you the probability of falling in that interval. And the probability is 0.09, so we want 4 decimal places. Remember, for 10,000, it says 0.994. We look one further. If this was 5, we would round up, but because it's not, we don't. So 0.994 is the answer here, 0.0994. Now, as a percentage, that would be 9.9%. But when they say probability, they want it as a probability, as a decimal like that. Now, Maria took the May version. In what interval must Maria score to claim she scored as well? Well, it's not going to be 510 to 540 because the May version has a different average and a different standard deviation. What we need to determine is that 510 and 540 for April, 510 to 540 for April is what z-score. Because if that's like plus or minus 1 standard deviation, then I need to do plus or minus 1 standard deviation for the May version. So I have to figure out what the z-scores for these. Now the formula for determining a z-score is the value minus the average. Now I usually use x bar here, but I'll use the proper symbol. Value minus average divided by standard deviation. So value minus average divided by standard deviation equals z-score. So for this question, I got to do 510 minus the average on this test was 480 divided by the standard deviation of 24. And then I also need to do 540 minus 480 divided by 24. And this little z-score formula is not given to you, so that's one of the few things that you're expected to know. That the value minus the average divided by the standard deviation, that tells you how many standard deviations away that value is from the mean. So 510 minus 480 divided by 24. First I get a z-score of 1.25. And 540 minus 480, I certainly expect a higher z-score here because it's further above the mean, divided by 24 is 2.5. So these are z-scores of 1 1/4 to 2 1/2. So 1.25 and 2.5. So those are the z-scores for the April version of the interval they gave us. So now we need to figure out for the May test. There's really two ways to do this. I could just use the z-scores, but let me actually do it the harder way first and show you that what we could do is we need to figure out that these z-scores correspond to what values in the May test. Now again, remember that the May test had an average of 510 and standard deviation of 20. So what value minus the average of 510 divided by 20 gives me a z-score of 1.25? And what value minus the average of 510 divided by the standard deviation of 20 gives me a z-score of 2.5 for the May exam? And so solving these little things here, I'm going to multiply by 20 and then add 510 in both cases. So I'll take 1.25 times 20 and then plus 510. And so that one's 535. And 2.5 times 20 plus 510 is 560. And this is my answer, 535 to 560. So the interval of 535, which came from this one, to 560, which came from this one. And so if Maria were to score in that interval, it would be the same z-score interval, the same probability that Joanne did in the April test. Now, what I did say was that we could get away with not finding these numbers, but I was wrong about that. I was going to say we could find the probabilities here, but they wanted the interval scores, so that's actually the only way to really accomplish that goal there. So this has a lot of good statistics in it. You know, average standard deviation, the probability of an interval, lower, upper, how to get the z-scores for those values, and then how to, given z-scores, find values. So using the z-score formula here is a big part of this. Remember, it's value minus average. I'll write that out a little bit here. Value minus mean divided by standard deviation equals your z-score. And this can be used to find the z-score of a value, or if you know the z-score, it can be used to find the value. And you know, these two tests have different averages. You know, one standard deviation away means the same percentages behind you. So like a score of 510 on the April test is 1.25 standard deviations above the mean. So whatever percentage is behind that, probably like 90% behind that, something like that. Well, the same thing if you get 535 on the May test, that's the same, you know, almost like ranking the percentage of students you did better on. This would still be 1.25 standard deviations above the mean for that test. So these two scores are equivalent for their respective tests, meaning you did better than that percentage of people, or that percentage of people did better than you, kind of ranking compared to the people that took the test along with you. All right, so z-scores are an important thing here, and how to use your calculator to find the probability of an interval with lower, upper, average, and standard deviation. And again, we get that from second VARs because it's a distribution concept. Choice 2, normal CDF. All right, that's it for sample 16. See ya.